Today, we're diving into the invisible bonds that are quite literally holding our world together. We're talking about everything from spaceships way out in the vacuum of space to oil rigs deep on the ocean floor. This is all about advanced welding and how it really does make the impossible possible.
So, let's start off with a little bit of a puzzle. What in the world could a spaceship, braving the frozen nothingness of space, possibly have in common with a deep-sea oil rig that's built to resist the crushing pressure of the ocean? I mean, they're total opposites, right?
Well, the answer, surprisingly enough, is welding. But, and this is a big but, we're not talking about your everyday run-of-the-mill welding. We are talking about some seriously advanced techniques that create bonds so strong, so reliable, that they let us build these incredible structures in the most hostile places imaginable.
Okay, so to really get why these new techniques are such a game changer, we first have to talk about the biggest, most fundamental challenge with welding the old-fashioned way.
Think about traditional welding. It makes sense, right? You just melt two pieces of metal so they flow together and become one. But that crazy intense heat, that's also its biggest weakness. It can totally warp precision parts, and even worse, it can mess with the special properties of high-tech alloys, actually making them weaker. The solution is something called solid-state welding, which, get this, joins materials without melting them. It completely preserves their original strength.
So, how is that even possible? How do you weld something without melting it? Well, this is where engineering gets really, really clever, by thinking on a totally different scale. We're talking about the atomic level.
At its heart, solid-state welding is all about encouraging atoms to make friends. Instead of making a big molten mess, it uses a super precise combo of heat, well below the melting point, and a whole lot of pressure. This basically convinces the atoms from one piece of metal to just cross the boundary and form powerful new bonds with the atoms of the other piece. It creates this perfect, seamless join, right at the molecular level.
So, why go through all this trouble? Because the results are just incredible. You get these exceptionally strong, super high-quality welds without any of the weak spots that feet can create. And that makes it absolutely critical for industries where there is zero margin for error. Think aerospace, defense, nuclear power, places where a single weld failing is just not an option.
Here's the cool part. There isn't just one way to do this. Engineers have come up with a bunch of fascinating ways to make it happen. So, let's take a quick little tour of these no-melt techniques.
First up, we've got friction welding, and this one is so intuitive. It's basically the same thing as rubbing your hands together to warm them up. You take one part, spin it at an insanely high speed, and then just slam it against a stationary piece. That intense friction creates a ton of localized heat, softening the metal right where they meet, until, bam, it fuses into one solid piece as soon as the spinning stops.
Next up, we've got a technique that literally uses sound. It's called ultrasonic welding, and it uses these super high-frequency vibrations, way beyond what we can hear, to create friction and heat between two parts. It is an incredibly precise method, which makes it perfect for joining small plastic components in things you use every day, in medicine, cars, and electronics.
But you know what? This whole idea of joining metal without melting it, it's not new at all. Actually, it's ancient. Blacksmiths have been using forge welding for centuries, heating metal up till it's glowing red hot and then just hammering the pieces together on an anvil. That's the original solid-state technique right there.
And now for something that sounds like it's straight out of science fiction. Cold welding. It uses absolutely no heat. See, here on Earth, there's this thin layer of oxidized atoms that keeps metals from just sticking together. But out in the pure vacuum of space, if you press two perfectly clean, flat pieces of metal together, their atoms will bond instantly, permanently. It's solid-state bonding in its purest, coldest form.
Okay, so from the vacuum of space, let's take a plunge into another extreme environment. The crushing pressure deep underwater. And this, as you can imagine, brings a whole new set of challenges to the table.
And this isn't some small niche thing we're talking about. It is a massive industry. The market for what's called hyperbaric or high-pressure welding is expected to be worth more than $338 million. This tech is absolutely vital for keeping our global energy and shipping infrastructure running.
So what is it exactly? Well, hyperbaric welding is basically like creating a little pop-up workshop on the ocean floor. A rigid chamber gets sealed around the area that needs to be fixed. All the water gets pumped out, and then the inside is filled with a special gas mixture that's pressurized to match the water pressure outside.
The whole process is just a marvel of logistics and engineering.
I mean, once that chamber is set up and pressurized, a highly specialized welder diver can actually go inside this dry habitat. This lets them perform really complex welds with the same quality and precision as if they were on dry land, all while being hundreds of feet beneath the waves. It's wild.
So, we've seen how we can weld without melting, and how we can literally weld at the bottom of the ocean. What does this all mean? What does it actually allow us to build?
The applications are just staggering when you think about it. We're talking about repairing the enormous steel legs of offshore oil rigs, sealing up underwater pipelines, even fixing the hull of a massive ship without ever having to take it to a dry dock. These are monumental jobs that, honestly, would just be impossible without this technology.
Now, you might be thinking, that sounds incredibly dangerous. But the data actually tells a very different story. A study that looked at commercial diving accidents found that when all the right safety procedures are followed, hyperbaric welding itself is actually a low-risk activity. That just goes to show how refined and reliable these extreme techniques have become.
So whether we're talking about manipulating individual atoms to bond without melting, or building a dry workshop on the seabed, advanced welding is just a perfect example of human ingenuity. It shows how we're constantly finding these brilliant ways to get around what seem like fundamental laws of physics.
It really makes you wonder, doesn't it? We can now create these permanent, super strong bonds in a vacuum, under immense pressure, with heat or with no heat at all. So, if joining materials together is no longer the barrier, what's the next impossible thing we're going to decide to build?